Today's lesson is going to be a review of simplifying expressions. We will be reviewing distributive property and combining like terms. So just a brief review of simplifying the expressions. An algebraic expression is a collection of real numbers, variables, grouping symbols, and operation symbols. Here are some examples. The terms of the expression are separated by addition. There are three terms in this example, and they are 5x squared, x, and a negative 7. Remember we said that the operation in front of the number, variable, or term is the sign of that term. The coefficient of a variable term is a real number factor. The first term has a coefficient of 5. The second term has an unwritten coefficient of 1. So when you see a variable by itself, remember that the coefficient is 1. And finally, the last term, negative 7, is called a constant. There's no variables with that term. So we're going to do this review and review two important skills. One, distributive property, and the second, combining like terms. Then we'll combine both of those in one problem. So distributive property. It's a way that we simplify an expression. Usually there are parentheses. So if you have A times the quantity B plus C in parentheses, we know that we can distribute the A through multiplication. And one way to make a simpler expression is to multiply A times B and A times C, and then finally add them together if they are like terms. So let's give this a try. In this example, we would want to distribute the 6. We would do 6 times x and 6 times 2. 6 times x plus 6 times 2 is 12. Okay, in this example, what we're distributing is a negative 4. So sometimes it's nice to circle that. And we're distributing it to the x, and then we're distributing it to this 3, which if you circle the operation in front of it, you will see to be a negative 3. So negative 4 times x, and then we're evaluating negative 4 times negative 3, which would be a positive 12. And when you write your positive 12, that positive plus sign becomes the operation between them. The same would be true if the outcome had been negative. It simplifies the operations in the middle so that we don't have plus a negative or minus a negative and so forth. So try the distributive property on this problem. So negative 7x and negative 7 times a negative 2 is a positive 14, and there's our simplified expression. Okay, this happens sometimes that we see parentheses and there's no number in front of it. It's as if we're distributing a positive 1, and when we do that we can just drop the parentheses because positive 1 times x and a positive 1 times a negative 2 doesn't change anything. But if we see the parentheses are preceded by a minus sign or a negative sign or a subtraction sign, however you want to see that, you have to almost write in a invisible or a negative 1 that you're distributing a negative 1 to both. So negative 1 times 4x, and then a negative 1 times a negative 3 becomes a positive 3. So that would be your simplified expression. So when you're multiplying everything by a negative 1, all of the terms inside the parentheses change their sign. So we started out with a positive, hold on a sec. We started out with a positive 4x up here, and we ended up with a negative 4x down here after distributing a negative 1. We have a negative 3 right here, and we end with a positive 3 right here. So distributing a negative 1 changes the sign of each term inside the parentheses. So like terms are the terms with same variables raised to the same power. The idea is that the variable part of the term must be identical for them to be like. So here are some examples of like terms over here. These are all like terms because these two have the same variable x with an exponent of 1, which is not written. These two terms have xy and xy, and they are identical. But over here, with the unlike terms, 5x and 8y could never be combined because they are not the same variable. Same with these, even though they both have the variable x and y. Notice that the exponent of 2 is with the x in the first term, and the exponent of 2 is with the y in the second term, and that does not make them identical. It has to be the same variable to the same power. We could change this one and make it the same if it were x squared y, then we could combine it with the negative 3, but that's not the case. So let's go ahead and work on this. First example, simplify. You could just simply identify the like terms and add their coefficients, and we talked about circling, squaring. You could change colors, you could do all kinds of things. So if I look at the first term, and I circle it, 4x, I look for any other terms of x, and I circle the operation in front of it. Again, I circle the operation so that I can see that as a negative 1x. You can also apply the integer rule where you add the opposite. Then I go to the next term, and I box it in, and I look for a term with y, and I see one here. So now I'm going to combine the circles and add the coefficients. 4 plus negative 1 is a positive 3x. Next, combine the coefficients in the boxes. A positive 7 plus a positive 5 is a positive 12, and writing the sign of that number between the terms gives my simplified expression. Let's try this. I circle the first term. Now I'm looking for anything with an x squared. Here's one right here. All right, next term has a variable y. I'm looking for a variable y. I do not see one. Next term, 4x, it's positive. Here's a common term. And finally, a constant. Now I've changed shapes every time I did this. You could keep going with that, or you could also do the underline. So you could underline the first term once, you could underline the second term twice, the third different term 3 times, and finally, so you could do the underline method as well. Okay, so let's combine the circles. So 4x squared plus 12x squared is going to be 16x squared. Negative 13y becomes minus 13y. My triangles here, a positive 4 plus a negative 3 is going to be a positive 1, and I don't have to write it. And then finally, plus 3. And I know there's 4 terms in the simplified expression, but that's as simplified as we can get, because when you look at the terms, there are no more like terms that can be combined. And our final example. So in this case, we have to do some distribution first. So there's 2 sets of parentheses. So I'm distributing 5 in the first, And then it's real important to see this as a -3 in the second. And I like to see that as a -7. So if I write my simplified version without parentheses, 5 times x, 5 times a -2, -3 times 2x, and a -3 times a -7. I go in and combine my like terms by circling them, or identify my like terms, I should say. And I'll end up with 5 plus -6, which will be a -1x, so I can write a -x. The -10 plus 21, I'll subtract them and keep the positive, so plus 11 is my simplified expression.